Hi guys, this is Anish. The agenda for the session is installation of Hadoop on a single node cluster. So I have got a virtual machine created on VirtualBox. You can create a virtual machine on VMware as well. That's also good. So let's start virtual machine. Currently we are using Ubuntu 12.04 version. You can use other versions as well, like 13.04, 14.04. This is quite a stable version, that's why we are using this version. Okay, so let me log in. It's asking my username. My username is Hadoop. I have created a user called Hadoop while installation. Okay, let me supply my password. Yes. So guys, this is a brand new machine. Nothing is installed previously in this. So let me check the IP address using ifconfig command. Yes, 192.168.0.104. I'm using putty. I'm using putty because putty will give me mouse control. .104. Okay. My username Hadoop and password. Okay, so I have logged into my system using putty. Let me increase the font size. Okay, so guys, why I am using putty? Because on this VirtualBox I can't use my mouse. I can't copy paste and all such operations are not available here. That's why I am using putty. By the way guys, for this session means we are using server version of Ubuntu. You can use the desktop version as well. That will also work fine. Okay. So currently nothing is installed. Let's start our manual and we'll follow all these steps available in this manual. So we are here to deploy Hadoop on single node cluster. Deployment of Hadoop in a single node cluster is also called as Hadoop in pseudo-distributed mode. What do I mean by pseudo-distributed mode? It means guys that the Hadoop will be deployed on a single machine, but all the daemons will be running as if it were deployed on a distributed cluster. That's since it is a single machine, that's why it is called pseudo-distributed mode. Okay, let's move ahead. So we'll follow all these things. Let's start with the very first topic, recommended platform. Yes. So guys, here the recommended platform for Hadoop is Linux. Although latest version of Hadoop are supporting Windows also, as we know that Yahoo and Microsoft has done a partnership. They want to make Hadoop, especially Microsoft want to make Hadoop compatible with Windows, but Hadoop is fully tested on Linux only. So almost all the places Hadoop is deployed in the production only on Linux. Nobody in the world is using on Windows. As I'm saying 99.99%. Okay, so that's why it is recommended to use Linux. For our installation, for our complete sessions, we are going to use Ubuntu and 12.04 version of Ubuntu. You can use the later version also, like 13.04, 13.10, 14.04. Why I'm using 12.04? It's pretty much stable version. Apart from Ubuntu guys, you can use other OS also, like CentOS or Red Hat. So usually in the industry, in the production, people are using Red Hat. Red Hat is the most popular version, as we all know that it is licensed version and very well supported community. So that's about the OS, recommended platform, and Hadoop. So guys, for our installation for our complete sessions, we are going to use Cloudera distribution for Apache Hadoop. So as we have already know that there are multiple distributions of Hadoop are available, like Apache, that's vanilla version, like Cloudera, which is the most popular version in the industry. Apart from these, there are other providers like MapR, like IBM, like Hortonworks, EMC is Pivotal. So these all are the versions are available, but Cloudera is the most popular in the industry. Apart from that, Cloudera is open source, as same as the Apache. Out of Cloudera's version, we are using CDH3. It means Hadoop 1, and its latest update, that is CDH3Ux. You can also use Apache Hadoop. All the similar steps you can use the same for Apache Hadoop as well, and you can use for 0.20.x or 1.x version. All these steps are pretty much valid and tested on Apache's these versions as well. Now, second point, what are the prerequisites? So guys, Hadoop is developed totally in Java, so it's recommended to use Oracle Java, and it's prerequisite to have Java installed. So it's recommended to have Oracle Java for the production, and for your testing and learning you can surely use OpenJDK as well, Open Java. Second prerequisite is passwordless SSH setup. So guys, Hadoop need passwordless SSH setup from master to all the slaves. This is required for remote script invocation. So this is the main point why it is required. When we start the services, suppose I am having a 100 node cluster. Now when we start the services, at that time, from master, all the services of the slaves will also started. All the services of the slaves will also started just from the master. So this type of work, for this type of work, we need a passwordless SSH setup. Okay, let's start with the first prerequisite, install Java 7. So firstly guys, we need to run the command sudo apt-get update. What this command do? Let me run it. It will ask you for the sudoers password. Let me supply the password. It is updating my source list. What sudo apt-get command does? It updates the source list. It means from the location from where it download and installs the packages. It's recommended always whenever you have fresh install, always run sudo apt-get update. Now we need to download the Java 7. So guys, let me show you. You can directly click on this link and you can download it. From here you can accept the license and you can download. So for our case, I have already downloaded so that it will save our time. Let me open WinSCP. So guys, WinSCP is a tool for transferring the data from Linux and Windows or vice versa. Let me go to desktop. Yes, I have the Java already downloaded. I have just dragged and dropped here in the Linux. So left hand side of the window is my Windows screen, Windows folders, and right side of the screen is Linux. Let me show you. It has available. Oh yes, now it is copied here. Java has been copied here. Now how to install Java? Let's follow our manual. So guys, make sure whenever you download the Java, you download as per your OS. If you are using 32-bit version of OS, you should download 32-bit Java. If you are using 64-bit OS, you should download 64-bit version of Java. Now, to install the Java, we need to untar the tarball which we have downloaded in the /user/lib/jvm. Okay, let me firstly create the directory. So guys, I have copied this command and I am pasting. Just right click it on the putty screen and it will be pasted here. Yes, the directory has been created. Let's check ls/user lib jvm. Currently it is blank. Okay, now let me copy the next command. What I'm doing, guys, I'm untarring this tarball, tar space xvf, and the path of the tarball, this tarball that we have just copied, -c, and this is the location where I'm going to untar this. The location, that the folder that we have just created, /user/lib/jvm. Yes, it is untarring the Java. Guys, installation of Java, there are multiple ways to install the Java. There are very simple ways also available. You can directly run sudo apt-get install Java, but this is one of the very nice way, feasible way. That's why we are using this way to install the Java. So Java has been untarred. Let's see the next step. Set the environment variable. Okay, we need to update .bashrc file and set or update the Java home or path shell variable as follows. Okay, fine. We need to export this nano.bashrc. So guys, same as vi, nano is an editor. I'm using the same. So I have copied this path /user lib jvm jdk 1.7.0_65. You please check path at your end and then supply path here. So this is my path, my system's path. So let me save it. I'll show you. I have already, yes, this path is of my system that I have set up here. Let me go at the end and yes, export Java home and path. So guys, this is the Java home, that is my Java installation directory. This is my Java home that I need to set in my environment variable file, that is .bashrc. .bashrc is the file where I can set all my environment variables. Then path is the location where all the commands are executed. We can get all the commands. So I am putting Java home /bin also here, so that I'll get Java C, all the things are available as a command. Okay, so guys, after this we need to run source. We need to source .bashrc. Now I can run Java directly. Java, yes, I can check Java version. Yes, I have got Java 1.7.0_65. Java has been installed. Java is working fine and I have got its version. I'm using Oracle versions, that's why it's showing hotspot. For your learning testing, you can use OpenJDK as well. That will also very easy to install, or but for the production, guys, it is recommended to use Oracle Java. So for Hadoop 1, guys, you can install Java 6 as well, but it's recommended to go ahead with Java 7. So that's why we have installed Java 7. Now the next thing is the next command, the next step is configuration of SSH. Now, so guys, Java installation, before coming to fourth step, Java installation is very easy. As I told you, there are multiple ways to install Java. You can directly install Java using the apt-get install command. There are commands available for that as well. You can use OpenJDK just for your learning. You can use this Java 6 as well, but this is the best configuration that is recommended to use with Hadoop. That's why we have installed Java 7, that is also from Oracle. Okay, the next prerequisite is configure SSH. So guys, SSH means secured shell, as we all know. we need to install OpenSSH server and OpenSSH client firstly. Let me copy this command. By the way, with most of the distributions it is already shipped, like latest version, all latest version of Ubuntu and Linux, it's already shipped with the this setups. OpenSSH server and OpenSSH client is already installed, same as in the, so it is downloading OpenSSH server. It will take few seconds to install. So guys, it is running fine. It has installed OpenSSH server and OpenSSH client by running this command. Now the next thing is we need to generate key value pairs. We need to generate this key pairs. SSH keygen minus T RSA minus P double quotes. So guys, why I'm generating these key value pairs, I'll explain you just in next few steps. That I need to set passwordless SSH. So let me run this. It will ask you the file name in which it want to save the key. Don't supply any file name. It will save automatically in .sh/id_rsa key file. Yes, it has saved. So if I show you the location ls.ssh, yes, two files has been created, id_rsa and id_rsa.pub. These are the two key pairs. id_rsa is my private key and id_rsa.pub is the public key. Let me show you the things here, guys. So what I want to set is passwordless SSH. Now if I want to set the passwordless SSH, this command will set the passwordless SSH. It means from by the way, this is a single machine. It means if I run, let me show you firstly, SSH localhost. Are you sure you want to continue? Yes, I want to continue. I want to connect. Yes. So guys, it is asking me the password. If I supply the password, then only it will allow me to log in. Let me show you again. SSH localhost. It is asking me for the password. I want to set my local machine to be set like passwordless SSH. When I run this command, it shouldn't ask me for the password, because we are installing Hadoop in a single node cluster. It means Hadoop will treat this machine as a master as well as slave. What do I mean by that? My Hadoop master component will automatically SSH to localhost and start the services here. That's why it is called pseudo-distributed. Okay, so what we need to do, we have copy this command and run it. As soon as I run it now, so guys, what I have done in this command, let me explain that as well. I have copied the content of id_rsa.pub, that is my public key content, in authorized keys file. SSH localhost. Guys, it didn't ask me for the password. Passwordless SSH is setuped. Passwordless SSH is setuped. Let me show you once again. What command I am running? SSH localhost. Enter. It didn't ask me any password. I have logged in without any password. Perfect. So guys, the funda behind this is we have got two mechanisms for the authentication. First is the password, but if you want to remove the password mechanism for authentication, you need to supply the second one, that is with the help of key pair. As I have already shown you, these are the two key pairs, id_rsa and id_rsa.pub. These are the two key pair, that is, one is the private key and another is the public key. So if I want to make any person, I want him to log into my machine without any password, I need to give him my public key. What I need to give him? Public key. So that guy will log in with the help of public key. Now my public key will match with the private key. If this pair is the correct, then the person will be allowed to log in. Same funda guys we have done here. What we have done, we have added the entry of public key in the authorized keys file. Whenever I from the same machine, if I run this authorized keys, when I run the SSH localhost, it will use the public key that is available here to log in, and it will match with the private key, that is ID_RSA. So for the real cluster, we'll see in the next session, that is setup of a real Hadoop cluster where we'll be having multiple machines. There we'll see how multiple machines on multiple machine we set up passwordless SSH. Okay, so for currently we have finished, we have done with our both the prerequisites. That is, the first one was, let me go back to show you that. First prerequisite is Java. We have installed the Java, we have installed the Java 7, Oracle Java 7, passwordless SSH. Yes, we have set up the passwordless SSH. So I can log in from my machine using SSH localhost command and without any password. So guys, prerequisite has been done. What next? Now we need to download Hadoop. You can directly download Hadoop. This is a direct download link. You just click on this link, Hadoop will be downloaded. Now to save the time, I have already downloaded this. Let me use WinSCP to copy the data from Windows to Linux. So let me drag and drop here. As I told you guys, left side of my screen is Windows and right side of the screen is Linux. So if I ls it here, yes, the data has been copied. Hadoop setup is copied here. Okay, now let's go to manual. What next? We need to install Hadoop. For the installation of Hadoop, first step is untar Hadoop. Okay, tar space xdf. Okay, let me type it for you. Tar space xdf space Hadoop. So it will untar Hadoop. Hadoop is untarred. Okay. So guys, usually in the production, Hadoop is installed on another location like /opt or some other location, but since we are learning, so that's why for current thing we can install Hadoop in our home directory as well. So you do not need to specify a number of different permissions, or you do not need to tell it like create different directories and provide the permissions. That's why we are directly installing Hadoop in the home directory, but in the production it is recommended to install in usually in /opt. Okay, so we have untarred Hadoop. Step 6.2, go to Hadoop home directory. Okay, so guys, this is my Hadoop home directory. This is Hadoop home directory, cd Hadoop. Your Hadoop setup directory, this is called Hadoop home directory. Let's check the content of this directory. In the bin, we have got executables. So Cloudera docs, these are having few docs. In the lib directory, we have got all the libraries available. In the src directory, we have got the source code available. In the conf directory, we have configuration files available. So we need to go inside the conf directory and we'll edit the configuration files there. Let's firstly use step number 7, setup configuration. So edit configuration file, that is conf/ in the configuration directory we have file hadoop env.sh, and we need to set java home. Okay, let's edit that file. I'm using the nano editor, nano conf/hadoop env.sh. Yes, I need to set Java home. Make sure you remove this hash, as hash means comment here. So I have removed it, and what is my Java home? I need to check firstly. Okay, let me check it. Java home ls/user lib jvm Java. This is my Java home path. We have already seen the Java home path, guys, when we installed the Java. So I need to just paste it here. You can right click on putty screen and it will paste. Yes, now save it. So let me help you with the nano editor also. If you press Ctrl X, it will ask you if you want to save or not. Press Y and then press enter. It will save. Okay, so guys, as Hadoop is developed in Java, it is mandatory to have Java installed and running. Java must be installed on your system. So the path, Java home path that we have set up in Hadoop env.sh, Hadoop will read that path. Hadoop will use that path for all its purpose, like when you start the Hadoop, when you format the name node, when you submit the MapReduce job, for all the purpose, Hadoop will use this Java home path that you have set up in the environment file, that is Hadoop env.sh. Okay, apart from this, guys, Hadoop env.sh is the Hadoop environment file where we set up environment related variables, usually like Java home. A very simple example for the same. So we have done with the step number 7.1. Let's go to 7.2. Now guys, this is important, concentrate here. Edit configuration file conf/core-site.xml and add following entries. Okay, so guys, let me show you conf/core-site.xml. okay, and we need to add following entries. We'll understand also. Firstly, let me copy it. Yes, I have copied these parameters here. So guys, this core-site.xml file, there are, by the way, multiple files for Hadoop configuration, as we are seeing core-site.xml, next is hdfs-site.xml, and so on. So in the core-site.xml file, we provide the parameter that is related to core of Hadoop. That's the main part of Hadoop. All those parameter we set up in the core-site.xml. This is very important file, like the location where your name node will run, like if you want to enable the trash, like if you want to set up like your directories, like this configuration file properties that I am showing you here. So guys, the first property that we are setting here is fs.default.name. fs.default.name. This property means the location where your name node will be running. The location where name node will be running. The location of your name node is this. So what we are specifying here? We are specifying hdfs:// your IP address. You can specify localhost, since we are working on a single machine. You can go ahead with the localhost, and the port number where name node is running. So fs.default.name is the location of your name node. Name node is the daemon, that is a master of HDFS. We know it. Name node runs on the master, but since we are working on a single node cluster, all 5 daemons will be running here on your single machine. So guys, fs.default.name, this property specifies the location of your name node. Okay, the first property. Second property is hadoop.temp.dir. So as the name is suggesting, it is the location of some directories. Yes, but guys, as the name is saying temp, it is not just temporary directory, it is all the directories. So guys, hadoop.temp.dir is the location where all the Hadoop's data will be stored, like its name nodes metadata, like its data nodes actual data, like MapReduce data, MapReduce temporary data, MapReduce system data, local data. All the data will be stored in this directory. So guys, this will be the temp, this will not this will be the root of all the directories. This will be the root of all the directories. Inside this location, n number of different directories will be created. Like there will be a different directory for DFS, there will be different directory for the name, that is for name node, there will be different directory for secondary name node. I'll show you once we installed Hadoop, then I'll show you this location. We'll go inside this location and we'll check it. So all in all, hadoop.temp.dir means the location where all the Hadoop's data will be stored. Usually in the production we specify the comma separated list of multiple mount points, multiple directories. So say for example, if I am having 10 disks attached to my machine, so those 10 disks are attached like they are mounted on /data1, /data2, /data3 and so on up to /data10. So what I can specify here is comma separated list. But guys, make sure you have right privileges on this directory. This path is sample path. Okay, let me give the correct path. So my correct path will be, I'm giving my home's location only, that is /home/Hadoop. Hadoop is my username, so I'm having this directory /home/Hadoop. Inside that a directory will be created, that is hdata, then Hadoop, then a username. So my username that I'm using itself is Hadoop, so a Hadoop directory will be created. Okay, let me save it. So guys, these are the mandatory parameters. There are a number of other parameters that we'll see later, that is available in your core-site.xml, but these two are the mandatory parameter that you must have to set it here. Now the next file is conf/hdfs-site.xml. okay, let me edit that, let me open that file, nano conf/hdfs-site.xml. yes. So guys, let me copy this, then I'll explain you. Okay, so guys, this file, this configuration file is used to specify the properties related to your HDFS, that is Hadoop Distributed File System. All our file system related properties we set in this, all our file system related configuration we save in hdfs-site.xml. So currently what parameter we are setting here, dfs.replication. So guys, as we know, the default replication of Hadoop is 3. The default replication of Hadoop is 3, but since we are working on single node cluster, creating 3 copy of each and every data is surely not recommended, because it will create it just on single machine. That's why we are setting this property to 1, that is dfs.replication to 1. So wherever you work on a single machine, single node cluster, you should set dfs.replication to 1. In an actual cluster, say suppose if you are having a 15 node cluster, there we usually set a replication factor of around 4-5. There are lots of factors which govern the replication factor, that we'll talk later. But yes, currently here for a single node cluster you should set this to 1, dfs.replication to 1. Let me save this, Control X, Y to yes. Okay, let's go to the next file. Okay, let me go downwards. Next file is map-red-site.xml. Let me open that file, nano conf/map-red-site.xml. So guys, in this map-red-site.xml we specifies the configuration properties that is related to your MapReduce. All your parameters related to MapReduce you can set up here. So there are, by the way, lots of properties in the map-red-site.xml, but the mandatory property is this map-red.job.tracker. map-red.job.tracker. This is the map mandatory property. This is the location of your job tracker. On this IP and port your job tracker will be running. So on localhost colon port number, that is 9001, on this IP and port job tracker will be running. These are the this is the mandatory property. There are a number of other properties also that we can set according to our requirements, but for a single node setup this is more than sufficient. Okay, so guys, let's save this file. Yes, Control X Y, save. Fine. So we are done with all our configuration files setup. Now let's set environment variables. Update.bashrc and setup or update Hadoop home and path shell variable as follows. We need to set up Hadoop home. Okay, export Hadoop home. Firstly, let me take the location. This is my Hadoop home directory. Okay, nano my home.bashrc. Let's go to the last line here. This is my Hadoop home directory. Okay, what parameters I need to set? Hadoop home equal to export Hadoop home is equals to this, and I need to set up export path equal to $path colon $Hadoop underscore home slash bin, so that I can use Hadoop's executable from anywhere, any place. Let's save this, and we can either source this or either we can type bash. Okay, now how to check it whether all the things are this environment variables are correct or not? If we type Hadoop, press enter, yes, it will give you this command list usage. Okay, so guys, all the configuration as well as environment variable setup has been done. This is the minimum requirement whenever you install Hadoop. This is the minimum configuration required. Now what next? Start the cluster, but before start the cluster we need to format the name node. So the command to format the name node is bin/hadoop name node minus format. But guys, with this I have written a note in the red mark. This activity should be done once. Excuse me. This activity should be done once. So guys, this activity should be done once when you install Hadoop. Else it will delete all your data from HDFS. Guys, this is a very important thing. By the way, in the production you are supposed not to even anywhere. Once you start your Hadoop cluster, everything is set up. Don't format your name node again. Don't format your cluster again. Otherwise you will lose all your data. So this activity should be done once. So guys, what exactly we do when we format the name node? When we format the name node, it creates all the required directories, all the required setups, if the directory doesn't exist. So if I show you before running this command, let me show you ls my home directory. Currently I am having just one directory here, that is Hadoop setup, Hadoop home directory. When I run this command bin/hadoop name node minus format, when I run this command, it will create all the necessary directories where Hadoop will store the data, where Hadoop will store its metadata, where it will store its original data, where it will create a directory for like secondary name node, JobTracker, TaskTracker, that is for the MapReduce. All the directories will be created. It is like, guys, means simply I would say, whenever we use any new system, we usually format our file systems, right? Same we are doing here. Okay, let me press enter, bin/hadoop name node minus format. Yes, whenever guys you format the name node, make sure you get this message, name node has been formatted successfully formatted. Our name node has been formatted successfully. Let me show you the content of now my home directory again. You can see guys, here I have got another directory created with hdata. Another directory has been created with hdata. I'll show you the content of that directory a little later, but let's move ahead. What next? We can start the Hadoop services with bin/start all command. So before that, let me show you what processes are running. If I run jps command, none of the processes running. jps command list out all the Java processes that is running on your machine, all the daemons that is running on your machine. Now if I start the services bin/start all.sh, look at this. Now guys, look at the messages here. Starting name node, starting data node, secondary name node, JobTracker, TaskTracker. This single script has started all the daemons. This script has started all the daemons. But guys, if I explain in a little more detail, it has started the name node directly. It has started the JobTracker directly. But for the data node, secondary name node and TaskTracker, it firstly SSH'd to localhost. It firstly SSH'd to localhost, then it started. It means guys, setup of passwordless SSH is compulsory. If you do not set passwordless SSH, it will give you a prompt. It will give you a prompt to enter the password, because processes can't take the can't supply the password on the fly. So that won't be the correct. So you must have to set up the passwordless SSH. Now let's run the jps command, which will list all the daemons, all the Java processes running in the background. So guys, all 5 processes are running, as we can see. Name node is the master. Name node is the master of HDFS. It is the daemon that runs on the master that for the HDFS. Data node is the slave for HDFS. JobTracker is the master of MapReduce. TaskTracker is the slave of MapReduce. On the other hand, secondary name node, which is used for the, it collects the data from the name node periodically. So in case name node goes down, it will be we can make secondary name node as a master. We can make secondary name node as a name node. That activity should be done manually. So guys, you will ask me why secondary name node is running here. Again, the answer will be, since we are working on a single node cluster, all these setups, all these settings, all these daemons will be running just on one machine. We'll see in the actual Hadoop cluster, we'll see that how these daemons will be running on separate machines. So on your master, when we set up on real cluster, we'll see name node and JobTracker will be running just on the master. We'll see this all such details in Hadoop cluster setup session. So guys, Hadoop is set up properly. Now let's understand, let's firstly see the web console of Hadoop. Let me show you here. Your IP, that is 192.168.0.104. in my case, you check your own IP, and 50070 is the port number of your name node. So guys, once you open this web console for your name node, it will give you all the required information. So this is the location where my name node is running, localhost colon 9000 port. This is the location where name node is running. It is giving you all the configuration, that is when it was started, version, compiled, upgrades and all. Browse the file system. This I'll show you in just in next few seconds. Now here it is the cluster summary. How many files and directories are there? Configured capacity, DFS, how much DFS we have already used, non-DFS used, DFS remaining, this much DFS is currently remaining, DFS percentage, that is currently we are using just 0%, DFS remaining, how many live nodes are there, I am having just one node, that is live, how many dead nodes are there, decommissioning, under applicated blocks and all such things. The complete information is available here. Okay, so let me show you the file system. Let's click on browse the file system. I'm clicking on the new window. it will point to the local host. You need to change every time one to the correct IP. Replace localhost with your IP. So guys, this is your actual HDFS file system. Let me show you the same. You can see this command here as well. bin/hadoop dfs-ls. This is the command. When you ls of your Hadoop distributed file system, look at this. We are getting /home. This the same directory that is available here. This home in your slash. The same directory is available here. Now let me show you few things. You can run Hadoop command from anywhere. Let me go to home directory, Hadoop dfs-mkdir. So guys, the complete list of this DFS commands we'll see in the DFS hands-on session in our DFS workshop, HDFS workshop. I'm just creating a directory. Like, let me create a directory of input. So if I create a directory input, it will create this directory in the home of the user. What is the home of the user? User's home is /user/username, that is Hadoop, and its home. This is user's home. /user/Hadoop is user's home. So input directory is created here. So if I want to copy the data, I can copy the data in here. dfs-copy from local. So all such command list, command manual will be available. Will discuss this HDFS commands, everything in HDFS workshop. So let me copy the configuration file, conf/core-site.xml. Yes, I have copied this file. Let's go inside. Yes, my core-site.xml, that file we have created is copied here. Let's see the content here. Again, I need to supply this IP address here because it will point to localhost. Yes. So if you can recall, guys, we have supplied there fs.default.name, hadoop.temp.dir. All the data is available, and we can see the same data from the command prompt also. Hadoop dfs-ls input. Yes, core-site.xml. We'll see the complete command list, complete commands of HDFS in the next session. But currently, let's see the location where the data is getting stored. Firstly, ls hdata. We have specified hdata. In the hdata, a directory is created, Hadoop/-Hadoop. Now here multiple directories is created. DFS is for your HDFS related data, and map-red directory is created for your MapReduce related data. Okay, let's go inside firstly DFS. Now if I press tab again, so guys, look at it here. Data directory is for your actual data. This directory is usually created on your slaves where actual data is stored. Name is in this directory, all the metadata will be stored. In this directory, all the metadata is stored. And in the name secondary, this directory, all the backup that the data retrieved by the secondary name node from the name node is stored. So let me show you the content of data. So guys, here we have got all these things like blocks being written, current, detach, in lock, storage, and all. Let me show you content of current. So I am having these blocks available, and a version file is there. So similarly, I am having a version file in the name as well, and all the metadata will be available in the name directory and name secondary. Let me show you apart from this map-red directory as well, map-red local. So here the data will be available for the TaskTracker to be deleted, that is temporary data. Here we'll be having the TaskTracker logs, private user logs, all such data that's temporary, as well as some logs, some system of data for the MapReduce will be stored here. Okay, so that's about our storage directory. This in this location all the data is stored. Apart from this, guys, let me show you the location where all actual parameters are available. As you have seen that I have just shown you 2 parameters in core-site.xml, but there are more than 50 parameters in the core-site.xml. Let me show you the location. So the location is src inside your Hadoop home directory, core. This is the file core default.xml. Let me open this file. Nano src / core / core default.xml. So guys, this is a file where all the parameters are available. All the parameters in that you can set up, that you can edit, that you can customize is available. So these are the default value of all the parameters, like authentication related parameters, like your trash. You can enable your trash, you can enable Kerberos, you can specify the log file size, you can specify log file count, buffer size, all the parameters. Skip the checksum. You can specify this your compression codec, which compression codec you can use. There are a number of different compression codecs available. Default codec, gzip codec, bzip2 codec, all these codecs are available. This is the location, that is fs.default.name. This is the property that we have edited. This is the property that we have edited already. This is the mandatory property. fs.trash.interval. If you set any parameter here, it will enable the trash. So there are a number of parameters. Now guys, this core default.xml file is the default properties. If you want to change these default properties, you copy those parameter and edit it. Change this parameter and save this parameter in core-site.xml. Similarly, we have got hdfs default. Here again in hdfs default we will having all the parameters related to hdfs that you can edit, that you can modify according to your requirements, like say your location dfs.name.dir. By default it is using hadoop.temp.dir /dfs/name. We have already seen this, that in the that your name.dir there was a directory called /dfs then name. Your web UGI dfs.permissions, you can disable permission if you set false here. You can specify all, you can edit all this parameter. What you need to do here, just copy the property and paste this property in your hdfs-site.xml and edit it according to your requirements. Similarly, we have got src /map-red/map-red default.xml. Here again we have got all the properties of MapReduce related properties. This is having almost 90 to 100 parameters. So you can change it, like your io.sort.factor. Let me show you a few important properties. We have changed the map-red.job.tracker, map-red.local.dir. So we have seen this map-red/local, and this is hadoop.temp.dir /map-red/local. We have this property hadoop.temp.dir. This path it will take from core-site.xml. Similarly for map-red.system.dir, map-red.temp.dir for temporary data. So guys, here we have got long list of parameters. We can change it. We'll discuss the important parameter out of this in next session. What are the important parameter? All in all, you can copy all the parameters, whatever you want to edit. You can copy from the default file and copy to the respective site file, that is core-site, hdfs-site or map-red-site.xml. Okay, let's go back to our manual and see what rest of this steps are there. So we have already started the services and we have checked all the daemons. All these 5 daemons are running. Guys, if any one of this daemon is not running, it means your Hadoop will not work. Hadoop is not working correctly. All 5 daemons must work, must run. Your JPS command should give, the output should give all 5 daemons. Now 9th step is to run the MapReduce job. Let's see the MapReduce job. Let's run a classic Pi example. Let me show you. By the way guys, we'll see all this MapReduce job in our MapReduce session. Hadoop jar Hadoop example Pi 1010. So guys, whenever we are going to run Hadoop commands, we'll use Hadoop. Always we'll use this Hadoop utility. Now to submit the MapReduce file, we'll use the jar command. We'll use this jar utility of Hadoop, jar option of Hadoop utility. Now this is the jar file that is shipped with Hadoop. This is always shipped with Hadoop itself. So for this file I'm using the Pi example. This file is having lots of examples, lots of pre-built example that is given by Hadoop itself is there. So there are 2 parameters, that is number of maps and values per map. Let me show you as soon as I run it here. So this is the first parameter is number of maps and the second parameter is sample per maps. So it has started a MapReduce job. The same thing we can see in the web console as well. Let me show you guys here. The port for the MapReduce is 50030. You can see the MapReduce job is running here. Currently 90% is completed, even 100% completed. If I refresh it here, yes, 100% completed. So guys, if I show you, this is the administration console of MapReduce. What is there? Running map tasks, reduce tasks, total submissions, your number of nodes, occupied map slots, reduced slots, and all such information it is showing you here related to MapReduce. How currently running jobs will come here, completed jobs will come here, retired or failed jobs will come here, and all your scheduling information will be here. Okay. So my MapReduce job has been finished and it has given me the value of Pi, although that value is looking little approximate. You can specify 1000, that will give you more correct value. Let's run a typical word count, classic word count example. So we have to create a directory. We have already created an input directory. Okay, let me create again directory. Let me use this command so that it will be very easy. bin/hadoop dfs -mkdir input words. Okay, I have created an input word directory. Now I'm copying the content of all the directories available in the conf directory. Now guys, here bin/hadoop dfs, whenever I want to interact with the hdfs, I'll use dfs option. When I need to interact with the MapReduce, I have used jar option. Now here let's see bin/hadoop dfs. So I have used dfs option here. This is an alternative of copy from local. You can use any of this. I'm using put here. So conf/star, all the files in the conf directory will be copied in input words. Let me show the same thing here. So if I go here, input words, if I go inside this, look at this guys, all the files that is available in the conf directory has been copied. Okay, now let's see the next command. Next command is your MapReduce submission command. Let me explain you. bin/hadoop, we need to use always Hadoop utility, or even alternatively, since we have set up the same thing in the environment, you can use directly Hadoop also. Jar, whenever you submit a MapReduce job, you need to specify the jar. Hadoop example.jar. This file is shipped with Hadoop. We are using the default jar file, default MapReduce jar file. Now in this jar file there are lots of examples. I am using word count. So earlier we have seen for Pi. Now I am running the word count example. Input words is the input directory that we have already created, and we have seen that there are already data available. This input words, and output words is my output location. As soon as I press enter, it will submit a MapReduce job. Look at this, guys. It has submitted a MapReduce job. It is giving first information. Total input path to process is 17. Since I am having 17 files available in my input directory. This 17 files. Let's see the MapReduce console as well here. It is showing how many total maps are there, how many maps completed. If I refresh it, 17 maps total, 13 completed. If I refresh again, 16 completed, 100% map is completed. Now reducer is starting. Yes, my MapReduce job has been finished. Now we have two ways to see the content. We can see the content here directly with the command on the console. If I run this command, bin/hadoop DFS, that is I want to interact with the file system. Cat is the command, -cat for see the output words /star. So it will give me all the output. But let's see the output. It will be pretty friendly if I see the output here. Output words. So guys, the output of MapReduce job will be, the name of the file will be part-r- something 000 or 0001 2 3 4 like that. Let's open this file. Before that, let me copy this IP address because it will point to localhost. Yes, it has counted all the words. You can see fs1 letter 2. It has counted all the words. Description 8. All the words has been counted. A 12 and so on. So this is a typical word count example. So by the way, we'll discuss this word count example in great details in MapReduce session. So guys, alternatively, to stop the cluster, you can run bin/stop all.sh. That this scripts are available in the bin directory. I can show you that bin. All the scripts are available here. We have used start all.sh. Similarly, you can use stop all.sh to stop all the daemons. And there is this Hadoop utility that we are using for each and every purpose. Apart from that, guys, we have start DFS and stop DFS command as well. Start DFS, start MapRed. If you want to start a specific daemon, we'll use these scripts in real Hadoop cluster, because in the actual Hadoop cluster where we'll be working on multi-node cluster, we usually first start the DFS, then we'll start the MapReduce individually one by one. So guys, we have set up Hadoop successfully during this session. What all the activities, if I summarize this session, we have deployed Hadoop on single node cluster, that is Hadoop in pseudo-distributed mode. What we have done here, we have seen what are the recommended platforms. We are using the Cloudera version, Cloudera distribution for Apache Hadoop, that is CDH3Ux. We have installed the prerequisite, that is we have installed the Java 7, Oracle Java 7 we have installed, and we have set up the passwordless SSH. These are the two prerequisite, configured passwordless SSH. Then after that we have downloaded Hadoop. I have already Hadoop downloaded. Then we installed Hadoop. We untarred Hadoop. Then we set up configuration file. Firstly Hadoop environment file. Then core-site.xml, where we specified the core parameter. In hdfs-site.xml we specified file system related parameters. In map-red-site.xml we have specified MapReduce related parameters. Then in bash rc file we set up environment variables, that is we have set up Hadoop home and path, so that we can use Hadoop from anywhere, Hadoop utility. After that we formatted our name node. Guys, again I am repeating, do not format your name node again. Now next time when you want to work on Hadoop, just start all, just run this command start all.sh and your Hadoop will be running. Let me show you that as well. bin/stop all.sh. So to stop the Hadoop when your work is done, please stop Hadoop, all the Hadoop daemons, and when you run the JPS, look at this, none of the daemon is running. Now next time when you again want to work on Hadoop, you just run bin/start all.sh. That's it. You do not need to run Hadoop name node format. You do not need to format the name node again. So if I show you the JPS command, look at this. All 5 daemons are running. That is name node, data node for HDFS, JobTracker, TaskTracker for MapReduce, and secondary name node for the backup of name node data. So we have tested that all 5 daemons of Hadoop are running. We have copied some data in the HDFS. We have created the directory. We have interacted with just 1 or 2 commands of HDFS. Then we have seen 2 examples of MapReduce job, how to submit the MapReduce job. Although this MapReduce job things we have seen very quickly, because we are going to see lots of examples of MapReduce and all the details of MapReduce in MapReduce session. We have seen that, and we have stopped the cluster. Apart from that, guys, we have seen the name nodes console. This is my cluster master console, which is having all the cluster summary. We have browsed the file system using our web console. We have seen the MapReduce administration console also. So guys, this is overall the complete details that we have seen about Hadoop setup, that we have set up the Hadoop on a single node machine. So guys, that's it about the single node Hadoop setup. We'll discuss the next details about Hadoop multi-node setup that we'll see on the cloud in the next session. Thanks for attending. Thank you.